Okay, let's wrap it up, finally, right, with algebra of functions. So here I'm going to do all the math speak, and then we're going to work them, and it should be easier once we get past the math speak, okay? So algebra of functions, sum, difference, product, and quotient of functions. So let f and g be two functions. So the sum of f plus g, the difference of f minus g, the product of f times g, and the quotient of f divided by g are functions whose domains are the set of all real numbers common to the domains of f and g. So common means intersection, okay? So I'm going to write that over here. Intersection. So common and intersection. And there's a symbol for intersection, just like U, like the upside down U, the horseshoe is union. The unlucky U is intersection. Okay, this is the symbol for intersection, as you will see right here. This is the intersection. So this means what the domain of the function f and the domain of the function g, what they have in common is going to be your domain for the new functions that we learn, that we build there, okay? I really don't ask you about domains, but that's just in case you ever come across it. I just want you to understand what that means later, if ever you have to deal with that in your math future, okay? All right, so let's look here. I'll do this in a different color. So here's the sum. You have f plus g of x. The definition of that, we go from this is to this, okay? So it's f of x plus g of x. Then we have the difference. You have f minus g of x. Well, the definition of that is f of x minus g of x. So you take one function and you subtract another function. Product, if you have f times g of x, the definition of that is f of x, one function, times another function, okay? And then the quotient is, of course, f divided by g of x, and then we would just, the definition of that is going to be f of x divided by g of x. So one function divided by another function. Now, as we know, you can never have 0 on the bottom, right, as in your denominator. That's like probably rule number 1 in math. Whole world implodes, black hole opens up. It's terrible. Like, we can't have it. So we have to write this little caveat over here, provided that g of x does not equal 0, right? Because we can't have 0 here. So these are the definitions of our functions. So that goes into play when we're solving these. I'm going to start with black, I guess. So here's the steps that I always tell all my students to do. We're going to start with f plus g of x, which you see that right here. First thing I suggest to do is to write it as the definition. So our problem says, let f of x equal 2x minus 1, and let g of x equal x squared plus x minus 2, okay? So this is our f of x, and this is the value. This is our g of x and his value. So first we're going to do is we're going to write this as the definition. So the definition is f of x minus g of x. So all I simply did here was I just used the definition of sum. So this is definition, DFN, that's my shorthand for definition. That's supposed to be an O. Man, sorry guys. Definition of sum. So now the next step that we're going to do, I'm going to change colors so you guys can follow maybe the steps here. Okay, changing colors. Now since we went from the definition of sum, we're going to take the value of f of x and plug that in place of this. Okay, can you see that? We're not going to use the name, we're going to use the value. So instead of having f of x, we're going to plug in 2x minus 1. Oh, hold the phone a minute. I see something I messed up on. Wish I could just I wish it was in person so y'all could be like, Miss Solins. Okay, here we go. Back to where we were. So now we're going to add the value of g of x, right? So what do you think that is? Or what is that? Yes, x squared plus x minus 2. I say I wish we were in class because I know there were about 3 of y'all, 4 maybe, that were like, you messed up. Okay, so what we did here is we just plugged in value. And usually I do 4. I'm going to see if I can fit it in. D, F, for the definition. Okay, there we go. Now the last thing that we have to do, new color, yeah, orange, is we have to combine like terms. So we only have one x squared. We always want it in descending order, so we start with the highest power. So x squared, that's a 2. And then now let's look at our x terms. We have a 2x and an x, so that's going to give us, yes, 3x. And then a -1 and a -2 gives us a, beautiful. So that would be, and this was combined like terms. Wow. Okay, that took forever. Okay, so that's how you do that one. Same thing with this one. We're going to write it as definition of difference this time, though, okay? So this is going to equal F. Let's try my patience. F of x minus g of x. Okay, and this is definition. I'm going to write diff. Hope y'all get that right, what that is. Okay, now again, we're just going to plug in the value. So we could do (2x minus 1), but this time it's a subtraction, so this is going to be minus. After subtraction, we always have to put anything after that in parentheses, right? So then now we're going to have x squared plus x minus 2. Cool. So we plug that in. Now this step is that we're going to distribute that negative to all the terms. So we got to distribute. Okay, let's do that. So we just copy and paste this first one, right? So it's going to be 2x minus 1. This, we distribute that negative, it's going to give us a negative x squared. Distribute it there, we're going to get a negative x. And if we distribute it here, that's going to give us a plus 2. Okay, now we combine like terms again. Orange. I'm going to use the same color because it's the same step. So again, we just have a negative x squared this time. We have 2x and we subtract an x, that's going to give us plus x. And so that was that one. Now we have a -1 and a +2, so that's going to give us a... Okay, and that would be our solution for that one. All right. And let's go down to the next one. All right, last ones. Oh, I just put that there again because it copied down. I guess I should have raised it to the top, but here we go. So we're going to plug this in for here. So our first one, we're going to need more room. I'm going to go up a little bit. Okay. No, I'm not. So we're going to do G f of x times G of x. So that's going to be 2x minus 1 times x squared plus x minus 2. And then how I like to do this is, since we're multiplying them, it's hard for me to FOIL. I don't like to do it that way. It gets messy in my head. So I do 2x times, excuse me, x squared plus x minus 2. And then minus the -1, and then the same thing, x squared plus x minus 2. Now all we got to do is just distribute the 2x and then distribute the -1. So I'm going to change colors real quick to dark blue, and I'm going to do that over here. So 2x, excuse me for a second. So 2x times x squared gives me 2x cubed. 2x times x gives me a positive 2x squared. And 2x times the -2 gives me a negative 4x. And then we've already done this on the last problem. So it's going to give me a minus x squared minus x plus 2. Okay, and then now we can just write our like terms, or combine our like terms, sorry. So 2x cubed, so minus x squared, that would be plus, and then minus 5x plus 2. That to me is just a lot easier than having to multiply that in 3 times and then that in 3 times. But do you, like however's easier in your head, do it that way, okay? So that is all for C. Now let's do pink and do D, okay? Okay, so D, we're going to do, again, the definition. So it's going to be f of x over g of x. It's supposed to be a parenthesis. Okay, so our f of x again is going to be 2x minus 1 over x squared plus x minus 2. Okay, so we have to see if this, once this factors, if there's anything that cancels. So let's factor our x squared plus x minus 2. Set this not equal to 0 because we're going to have to find our domain. So we have factors of 2, opposite signs that are going to subtract to give us 1. So x squared tells us that there's 2 x's. Bigger sign gets the plus. So our factors are x plus 1 and x minus 1, so they won't cancel. So we can write it again as minus 1 over x plus 2. Wow, that doesn't look like anything I meant to. All right. And then our domain would be, you could do it on a number line and do that. I'm just out of room, so let's go ahead and do it though. Let's do it correctly. Let's not cheat or be lazy in our math, okay? So we know it's any real number except -2, 2, or 1. So it could be negative infinity. It's not even what I meant to do. Negative infinity to -2. Oh my gosh. Then we're going to union, pick back up at -2, and go to 1. Union, I'll have to write it down here, and then go 1 to infinity. Man, my infinities aren't even touching. Those are infinities, y'all. And this would be our domain. Because these are both there you go. That's what it is. These are both polynomial, so our exclusion here would have to be it. And we found that because of the bottom. Okay, so are they the same function? So do any of these functions look like the ones that we started with? They don't, do they? So you're right. They are not. No. My gosh. They are not. Smiley face. We are done with this one. All right, you guys. Have the very, very best day.